This is the last section we have for this course. Section 10.8 is division with polynomials. Two different types of polynomial division we're going to look at in this section. The first type is just considered division with polynomials. Here we will rewrite the polynomial with each term fraction as the sum or difference of fraction. So instead of having one big fraction, we're going to divide it out into individual fractions. And then we will divide each term in the numerator by the monomial denominator and simplify that fraction. So that type of division with polynomials is what's going to happen when we have a monomial denominator. For the other problems, we're going to use the division algorithm, which is for polynomials p and d. The division algorithm gives p over d equal q plus r over d, where d is not equal to 0, and where q and r are polynomials. And the degree of r is less than the degree of d. Clear as mud, right? I will do a little bit of annotating here to kind of give you an idea of what they're talking about. It isn't as random as it seems. They're considering d your divisor, q is your quotient, r is your remainder. Example number 1 is 3y squared plus 7 over y minus 1. Before I jump into this one, this is going to use the division algorithm, which is really long division. Hopefully, you all remember long division. If I have 25 over 4, if I go back to my grade school days, that's 25 divided by 4. You would see how many times 4 goes into 25. 4 times 6 was 24. There's 1. This is my dividend. This is my divisor. The 6 is my quotient. And the 1 is my remainder. So my answer would be 6, remainder 1. With the division algorithm, we're doing long division. What you have to remember is that each term needs to be represented. I have a y squared term. I don't have a y term, so I'm going to replace that with 0y plus 7. This is your dividend. Your divisor is y minus 1. And you are going to multiply. It's a little easier than doing division with long division because you want to make sure your first term matches exactly. Y times what is going to give me 3y squared? My answer to that is 3y. 3y times y is 3y squared. 3y times negative 1 is negative 3y. And then if you remember in long division, you subtracted. Right here I took 25 minus 24. So I'm subtracting. 3y squared minus 3y squared is 0. 0 minus a negative 3y is positive 3y. And I drop down the plus 7. Y times what gives me 3y? The answer is plus 3. 3 times y is 3y. 3 times negative 1 is negative 3. Remember, I'm subtracting those. 3y minus 3y is 0. 7 minus a negative 3 is 10. The the way I write my solution or type it into Hawks. My answer here is my quotient, 3y plus 3, plus my remainder over my divisor. So what I would type into Hawks would be 3y plus 3 plus 10 over y minus 1. Good old-fashioned long division. Hit the wrong button. Example number 2. This is an example of being able to do simple polynomial division because I have a monomial here in my denominator. So I will rewrite this fraction as each term separately. Negative 6x minus 3x plus 9 over negative 3x. And then I'm going to reduce. The x's go. Negative 3 goes into 6 2 times. This leaves me with 2 here. Negative 3 goes into 9, negative 3 times. So this leaves me with minus 3 over x. Example number 3, I have 5x squared minus 5x minus 10 all over 5. Again, I separate these into individual pieces. Not negative 5x squared. Positive 5x squared over 5 minus 5x over 5 minus 10 over 5, and I reduce each fraction separately. The 5's divide out, leaving me with x squared. 5's divide out, leaving me with a negative x. 10 goes into 5 2 times, leaving me with minus 2. So here I have x squared minus x minus 2. Example number 4, we have 6t plus 6t squared minus 9 all over 2 plus 2t. The first thing I want to do is reorder this so it goes from highest power to lowest power. So 6t squared plus 6t minus 9 over 2t plus 2. And I'm going to need to do this one with the division algorithm or long division. I have all the terms I need for this one. I don't need to add any placeholders. 6t squared plus 6t minus 9 goes inside, divided by 2t plus 2. I take 2t times what to get me 6t squared? The answer to that is 3t. 2t times 3t is 6t squared. 3t times 2 is 6t. Can I subtract? 6t squared minus 6t squared is 0. 6t minus 6t is 0. Bring down the negative 9, and that's actually going to be my remainder. So my solution here is 3t minus 9 over 2t plus 2. It would also accept 3t plus negative 9 over 2t plus 2. It would accept either one of those solutions. Example number 5, we have m cubed plus m plus 2 divided by m plus 1. I do need a placeholder here. M plus 1 is going to go on the outside. Inside, I have m cubed plus 0m squared plus m plus 2. M times what gives me m cubed? The answer to that is m squared. M squared times m is m cubed. M squared times 1 is m squared. Subtract those. M cubed minus m cubed is 0. 0, m cubed minus m cubed is negative m cubed. Drop the m. Plus m. M times what gives me negative m cubed? And the answer is negative m. Negative m times m is negative m squared. Negative m times 1 is negative m. And I'm going to subtract these. Negative m squared plus m squared is 0. M plus m is 2m plus 2. M times what gives me 2m? The answer is plus 2. 2m times m is 2m. 2m times 1 is 2. When I add those together, subtract those, I get a 0. So there's no remainder here. So my solution is m squared minus m plus 2. And if you remember when you did long division, if you had a remainder of 0, it meant that it divided evenly into your number. Same thing is true here. M plus 1 divides evenly into m cubed plus m plus 2 because my remainder is 0. This is going to be useful when you get to college algebra especially. Our next problem, example number 6, is x to the third plus x squared minus 32x minus 12 over x squared minus 5x minus 2. Once again, long division. This time, no placeholders are needed. I'm going to do this up a little higher because I think I'm going to run out of space. X squared minus 5x minus 2 is on the outside. X cubed plus x squared minus 32x minus 12 is on the outside. X squared times what gets me x cubed? The answer is x. So that actually gets put above the x term. X times x squared is x cubed. X times negative 5x is negative 5x squared. X times negative 2 is negative 2x. Subtract those. X cubed minus x cubed is 0. X squared minus a negative 5x squared is x squared plus 5x squared, which gives me 6x squared. Negative 32x minus a negative 2x is negative 32x plus 2x, which gives me negative 30x, and then I drop down the negative 12. X squared times what gets me 6x squared? The answer is 6. 6 times x squared is 6x squared. Negative 5x times 6 is negative 30x. Negative 2 times 6 is negative 12. Once again, when I do subtraction, I have 0, so there's no remainder. So my solution here is x plus 6. Example number 7, we have 2c cubed minus 4c squared plus 2c plus 8 over 2c squared minus 6c plus 8. I've got cubed, squared, 1, 0. I don't have to worry about putting in a placeholder. So I have 2c squared minus 6c plus 8 going into 2c to the third minus 4c squared plus 2c plus 8. 2c squared times what gets me 2c to the third? And the answer to that is c. C times 2c squared is 2c to the third. C times negative 6c is negative 6c squared. 8 times c is 8c. Subtract those. 2c cubed minus 2c cubed is 0. Negative 4c squared minus a negative 6 is negative 4c squared plus 6c squared, which is 2c squared. Negative 2c minus 8c is negative 6c. And you drop down the 8, and that gives me plus 8. C squared times what gets me 2C squared? The answer to that is 1. We have 1 times 2C squared, which is 2C squared. 1 times negative 6C is negative 6C. 1 times 8 is 8. And once again, remainder of 0. So my solution is C plus 1. Example number 8 is 3C cubed minus 4C squared minus C plus 2 all over C minus 1. I have a third squared single 0. C minus 1 goes on the outside. 3C to the third minus 4C squared minus C plus 2. C times 3C squared gives me 3C to the third minus 3C squared. Subtract those. Negative 4 plus 3 is negative C squared minus C. C times negative C gets me negative C squared. Negative C times negative 1 is plus C. Subtracting those, negative C minus C is negative 2C. Drop down the 2, plus 2. Negative 2 times C is negative 2C. Negative 1 times negative 2 is positive 2. Subtracting those, my remainder is 0. So here my solution is 3C squared minus C minus 2. Example number 9, we have 5x to the 5th minus 8x plus 7 over x to the 3rd. Here we're going back to the simple polynomial division. So I will rewrite this as 5x to the 5th over x to the 3rd minus 8x over x to the 3rd plus 7 over x to the 3rd. And I will reduce what I can. X to the 5th over x to the 3rd becomes x squared. So I have 5x squared. 8x over x to the 3rd becomes negative 8 over x squared. And I can't do anything with 7 over x to the 3rd. So this is my solution. We have 5x squared minus 8 over x squared plus 7 over x to the 3rd. Problem 10, 2x to the 4th minus 3x squared minus 8x minus 1 over 2x. Once again, we can do that simple polynomial division here. Rewrite it as 2x to the 4th over 2x minus 3x squared over 2x minus 8x over 2x minus 1 over 2x. And now when we simplify, the 2's divide out. We're left with x to the 3rd. Here that x divides out. I'm left with negative 3x over 2. The x's go, the 2 goes into 8 4 times, so I have minus 4, minus 1 over 2x. So my solution is x to the 3rd minus 3x over 2 minus 4 minus 1 over 2x. I think I want to do one more problem. Actually, I may do 2 more. I don't think this one's going to have a remainder. We didn't get very many examples with a remainder, so let's see what this one ends up with, and if I don't get a remainder, I will do another one like this with a remainder. This one, I am going to need some placeholders. So I've got m plus 3 on the outside. I have m cubed plus 0m squared plus 0m plus 27. M times what gives me m cubed? My answer is m squared. M squared times m is m to the 3rd. M squared times 3 is 3m squared. I subtract those, I end up with negative 3m squared plus 0m plus 27. I'm going to bring them all down. I guess, no, I won't bring the 27 down yet. M times what gives me negative 3m squared? The answer is negative 3m. Negative 3m times m is negative 3m squared. 3 times negative 3m is negative 9m. I subtract those, I end up with 9m plus 27. 3m plus 3, m times what gives me 9 plus 9. 9 times m is 9m. 9 times 3 is 27. My remainder is 0 again. So I have m squared minus 3m plus 9. Let's do this problem. M cubed plus 7m squared plus 12m plus 16 over m squared plus 4m plus 2. So the m squared plus 4m plus 2 goes on the outside. On the inside, I have m cubed plus 7m squared plus 12m plus 16. M squared times m will give me m to the third. So I have m to the third plus 4m squared plus 2m. When I subtract those, 7 minus 4 is 3m squared. 12 minus 2 is plus 10m. Bring down the 16. I have plus 16. 3 times m squared gets me 3m squared. 3 times 4m is 12m. 3 times 2 is 6. When I subtract these, 10 minus 12 is negative 2m. 16 minus 6 is plus 10. So here my solution is m plus 3 plus negative 2m plus 10 over m squared plus 4m plus 2.